Quiet, please.
Okay, Kelly, the first question is, shortly after you built the U-2, you knew eventually it was going to be shot down, and that was the seed that created you starting to think about the SR-71.
We knew that in overflying Russia for 4 years that they were making important advances in radar and missiles. And so in 1958, 2 years before Gary Powers was shot down, we decided we'd try to make a follow-on airplane, which became finally the SR-71, to fly higher and 4 times as fast. So that's the connection between the grandfather type and the SR-71. Now the SR-71 is one huge flying fuel tank, carries a great deal of fuel, and carries a pilot and a radar operator. And they're in the 2 areas ahead of the fuel tanks. In the chines, we have various pieces of equipment, cameras, radars, radios, things of that nature. And we come here to this splendid power plant built by Pratt & Whitney, the only one of its kind in the world. It's a Pratt & Whitney J58 turbo ramjet. The thing that's unique about it is that it operates as an ordinary turbojet engine until it gets up to around 1,600 miles an hour. And at that point,
Rolling.
we come here to the nacelle that holds the Pratt & Whitney J58 engine, the only one of its kind in the world. It is designed on a principle that it works as an ordinary turbojet engine up until about 1,600 miles an hour. Then at that speed, it shifts its actual cycle and becomes a ramjet, where the afterburner is providing practically all of the thrust from the engine. The exhaust system of the airplane is very involved. 35% of the thrust pushing the airplane comes from that tail ejector. That was a very difficult design job because the temperature of the air that comes out of the engine is running around 3,500 degrees Fahrenheit. And that's enough to melt any of the metals we use, were it not for the fact we mix the outer perimeter of the jet with air, which we draw in through those open vents that you see. These tail flaps adjust so that the engine tends to run at a constant speed, regardless of airspeed, altitude. Of course, here we have the tail section, and you see that.
Okay.
Camera's rolling.
Scene 3.
Take 1.
Good.
Those flyable rudders are one-piece elements that are automatically controlled in case of an engine blowout, so they crank in the proper amount of rudder to take care of an engine out on one side. They operate very, very fast. It took the pilots a long time to know which engine would blow when we were doing the early testing, because it was such a fast operation they couldn't tell. They knew they had a blowout, but they didn't know whether it was the right or left engine until we got on the ground and read out the tape. The controls, of course, are largely here on the trailing edge of the wing. And we have on the wing itself, which is a basic delta planform, a conical camber, which is a twist that gives us better crosswind landing characteristics and less drag when we go supersonic. It's washed out, as you see, when you get to the tip. We have chines on the nacelle as well as on the fuselage. The chines are these sections that stick out here. And the shape is such that it minimizes the radar return. So you notice that the leading part of the fuselage also has essentially a small delta wing.
And action.
We have here the inlet to the engine, and this is what we call a spike. That element is moved fore and aft automatically, so that we position the shock wave so that it hits on the leading edge of the cowl, and we get the maximum amount of what we call ram from the air at high speeds. That spike has to have an operating force at times of over 30,000 pounds, so you can see that how much load develops on the spike. It is made of high temperature plastic, and the very tip, of course, is titanium.
Okay, that. Action.
It's been said on occasion that the SR-71 and the Blackbirds in general are slide rule airplanes. I guess that's certainly true, because in 1958 we didn't have the kind of computers that we have today. But the slide rule has been a very effective tool for me for many, many years. In fact, they call my 12-inch slide rule a Michigan computer. It's been a very useful thing to have. I think it'll be a long, long time before we have an airplane that has higher performance than the SR-71, because the need for it is not there in terms of the fact that we can have satellites circling the Earth in 90 minutes, and we do not have to go any faster than what we go with this one right here, and it'd be very, very expensive to go Mach 4 or faster. So we may be seeing here the highest speed military airplane that there will be around for a long time.
Perfect. I have scene 6, take 1. Beginning.
When you think back to 1958, when the basic design work on the prototypes for this airplane was being designed and built, we had to make use of the Michigan computer, which is a 12-inch slide rule, and it did its job quite well. I've often been asked, what about the shape? How did the shape get to be derived to be a combination of delta wings and chines? Well, actually, there were the requirements for not only aerodynamic ones, but also to reduce the radar cross-section. And by use of the chines, you could reflect some of the radar waves away, not back to the source. I've been asked time and again, what is the next airplane to follow the Blackbirds? I don't see the requirement for higher speeds and probably not higher altitudes. We seem to be going as fast as we need to go and as fast as is prudent financially with the SR-71 and its associated airplanes. I don't know if there's going to be a faster military airplane built by our government in the foreseeable future. I can see unmanned drones taking over the reconnaissance job, and that in combination with satellites will do much of the work that the SR can do, although the SR is independent of weather and carries enough of a radar so that we can look through clouds and do what's required today. Thank you.
Okay, that's a cut.